All right, if everyone else is ready, I think I'm ready. Check. Yeah, it's on. Am I not being heard? Yeah, I think they're hearing me. I can hear it. I can't hear much of it, but I can hear it. People in the back here okay? No response. I got it. One thumbs up. That's good enough for me. So my name is Jared Brees. I will be giving once I find where my window went that actually controls the presentation, giving the talk on password cracking. It sort of delved into general password security and two-factor auth and a bunch of fun stuff regarding password security. So hopefully you learned something from it. I'm mostly self-taught. I did take a computer course at the CTAN course at Central Campus my senior year in high school, so that's my formal training. I'm not an expert. If you want to prove me wrong on something or have a question, shout it out. I'm by no means an expert or know everything, even about the topics I talk about. This is my home lab, as I've been told it's called. I didn't know that the term home lab existed until the people on the SecDSM Slack channel told me about it. I just thought it was a server rack in my little geek hut, but apparently I can call it a home lab now, which sounds a lot cooler. The types of password cracking that I'm going to go over will apply to passwords in all these spots. So anywhere that a password is stored in a fashion that it can be checked, in other words, in the manner that these are stored. So login passwords, username, password, websites, computer logins, etc. These passwords I'm not going to go over. I'm going to touch on Wi-Fi briefly at the end, but PIN codes, random login codes for firmware-y things, not really the stuff I know how to deal with. There are a few different ways that passwords are stored. One is clear text. If you ever come across a password that's stored in clear text, tell the system admin they're doing it wrong. It is what it says it is. It's just clear text. It's like storing it in a text file. There's simple hashes, which aren't salted. Think MD5 checksums. It's like, oh, hey, it's a hash. Well, yes, it's better than a plain text document, but it's really not that much better, especially if it is, in fact, just MD5 or just SHA or something that is very fast to crack. Salted hashes are better. One of the things you'll see this in a lot is, or I see it in a lot, is Linux shadow file. This typically uses an SHA 512 salted hash to store passwords, which is decent security, assuming your password is decent, but as we'll go over in a bit, it can be cracked just like everything else. A better way to do it is something computationally expensive. So the whole gist of password cracking is you have this thing called a hash. That's how the password's actually stored. What a hash is when the password goes through some magic algorithm and it puts out a hash. And the hash is a fixed length, so there can be what are called collisions. Anytime two passwords were to come out with the same hash, that would be a collision. But considering the size of the number of possible hashes there are, it's very unlikely that it'll happen. So anytime you come across a collision, it's likely because you just found the password. And that's basically how password crackers work, is they just try password after password after password until they get one that matches the hash they're looking for. They're like, oh, hey, there it is. If I can have Ben come up and talk just a little bit about Argon 2, I think that's on my next slide. Here, I'll jump to this slide. Argon 2, to go into a little bit more of the why it's computationally expensive, because I'm bad at explaining that.
I'll just try. But I don't like storing passwords. I like multi-factor. I like to devalue passes. But if you have to store them, they're going to be here for a little while. A salted hash doesn't really do it for me. I think that's pretty basic. So what do you do beyond that? There's really 4 different leading techniques to try to store your passwords in an expensive hashed manner. So there's something called PBK DF2. Anyone heard of that? All right, that's kind of old school. It's really GPU friendly. So the guidance is really not to use that. If you're going to use it, 100,000 rounds for a work factor. Then you can work up to bcrypt. That's real popular. Anyone use bcrypt? Heard of that? It's in a lot of frameworks. It's good to go. It's a little better, quite a bit better in PBKDF2, but there's still some things that are easier on the GPU side. Then there's something called scrypt. Anyone heard of that? Okay, scrypt's getting a whole lot better. So you have both CPU and some memory hardness baked in. And then there's the one that Jared mentioned, Argon 2. And there's two flavors, Argon 2 and Argon 2i, which has a combination of both memory hardness and CPU hardness. So you can GPU the thing, but you need a ton of memory to complement that. So that makes the work factor for bad guys quite a bit harder. So I'll leave it at that, but if you're going to store passwords, that's one of the leading practices. Otherwise, scrypt, bcrypt, or PBKDF2 if you have to. And now I'll hand it back to you.
Thanks.
Sorry, one more thing. When we were talking about the hashes earlier, those are pseudo-random functions, really deterministic, super fast. PBKDF2, bcrypt, scrypt, Argon 2, these are what's called key derivation functions. There's a fundamental difference in how they will do stretching or derive that key, which makes it much harder for the adversary. Sorry, that's nerdy, but I wanted to say that.
And that's why as a password cracker, I like it when people store their passwords a bit more like this. This is a example from a Unix password file from one of the ISU CDCs. I don't remember if this was the latest one or one before. This is the Unixy style, Linuxy style storage method. Let me see if I can enable my little laser pointer toy here. Hey, there it is. So this $6 is what indicates the hash type. So that tells you it is the SHA-512. Right here is the salt. By default, most Linux distros, at least all of them that I know of, will go ahead and salt your passwords for you, and they'll include a unique salt with each password, which is good because, as I mentioned before, the salted hashes are a lot harder to crack because it's basically throwing some extra crap in with your password that then the computer has to try and calculate if you're going to run it through a cracker to crack the password. And then the rest of this, all the way down to the colon, is the SHA-512 hash, and then some extra stuff that's in the shadow file that I don't remember what all it does, but I don't care about it if I'm just looking for the password. I went over this a little bit. So there are a few different ways to crack passwords or methods to it. There's the brute force. You're trying the letter A. You're trying the letter B. You're trying the letter C. After you get done with all that and all the single characters, you try A. You try A, B. Just everything until you get it. Dictionary attack is you feed it a word list. Word lists are awesome. They can be stolen. They can be generated. Stolen is like the RockU hack or Yahoo's big hack. Anything where you somehow manage to get a bunch of passwords. You can then use that as a word list because people tend to be like each other in their password choices for some reason. They like things like password 123. Don't know why. But there you have it. So stolen lists are really good word lists. Also, if you know your adversary, in terms of trying to crack their password, you can generate a word list. For the Iowa State competition, I managed to generate a word list, and then Jake told me about a technique that basically obsoleted it. But this still works for other things. If you, example, the Debian distros base their names off of Toy Story characters. If you knew of some organization that had sort of a theme, then you could come up with a bunch of, words and stuff that apply to that, make little tweaks to it, and just have something, that just spits out every possible combination. And whether you're using Hashcat or not, which Hashcat provides great options for this, then you'd be able to use something like that and potentially get more combinations out of it. Rainbow tables is another way. Effectively what that is it's pre-computed. You go through and compute everything ahead of time, or somebody else does, and then you buy it from them. There is a place online that sells actually 6 terabyte drives that's just full of rainbow tables, which I think is awesome. And it's basically just a big lookup table that, this hash, this password. I think it's for NTLM. I don't remember for sure. I could look it up, though. Let's see. We have... Got lost here. So one of the things that annoys me about password security is entropy versus the requirements. So entropy is how random the password is. Ideally, you want your password to be as random as possible. Therefore, people like me can't guess it. if the website has stupid requirements, like it has to be between 5 characters and 10 characters, and it can't include any special characters, that's a very good sign that they're storing it in plain text, and that's not good. Hash functions don't really care about how long the input is. If you can SHA 512 a movie, a Blu-ray movie that's 25 gigs, I don't think your 58 character password is going to hurt it too much. It might take a little bit less time, in fact. But there's no real reason, apart from potentially bandwidth constraints once you get into maybe a few thousand characters, to limit really how long a password is on a website. So if they do, be skeptical of it and question why. They can be enforced a couple different ways. Some I've seen that actually run it through post side. A lot of it's just JavaScript. Sometimes you can get around some of these by tweaking the JavaScript code and hitting submit, and it'll take it anyways. But then you have to do that every time you log into that website, so it gets a little bit annoying after a while. But feel free to play with it. JavaScript validation is always something I find amusing. An example of length versus complexity and a bit of entropy. So you could have an 8-character password that has everything in it. It has uppercase, lowercase, symbols, etc. Versus a 20-character password that's just lowercase letters. And in this case, the one with the 20-character lowercase, because it's so much longer, would actually likely be a better password because there are more possibilities than the 8-character one. If you're brute forcing it, then, and you know that it's one of these two, I'd hope that you pick the 8-character so I can guess it. The best case would be that we have typable characters, or even maybe non-typable characters. You use different passwords for everything, which I'm sure most of you already know. But that way, if something gets stolen from somewhere, then it's not really that much of a problem because they can't use it on your other accounts. Because typically when they steal stuff, they steal more than just the passwords. They steal usernames, they steal names, etc. Why so many like to make you not use symbols, I don't understand unless they're storing their passwords wrong. Perhaps there's an issue with input sanitation that they haven't quite figured out. But by forcing people to not use symbols, it reduces entropy. So if any of you are running a website that does this and can make it not do that, that'd be awesome. Character level entropy, I just threw some of this in here for the fun of it. I figure that if you're using every possible character that you can just type with either a single keystroke or shift in a keystroke, there are 95 possibilities. So when you add that up over the course of a password, it could get to be pretty unruly, which makes the hacker's life difficult. This is an example of what not to do. This is DMAC's website where I went to college. Just got my AA there, didn't take any InfoSec. The pin must be 6 characters long, no more, no less, 6 characters. It must contain letters and numbers. Now, it doesn't specify uppercase and lowercase, but given that information, the word list to crack all these would only be, let's see, what is it? Where was I? Give me just a second here to find myself. Oh, here it was. So here was the part of the calculation, and here was the rest of it. Around 300 gigs. Once you factor out the stuff of the deduplicate, so the word list would be that many lines. 42 billion is that, and then around 300 gigs. So if you are willing to store 300 gigs and you manage to get even if they were storing them properly, the hash dump, you could crack every single one of those. Which 300 gigs isn't a lot of data anymore. It used to be, but anymore, I don't even know if you can buy drives that are new that are that low of capacity. So it's not really that out of reach. If you're trying to crack it over the network, it's out of reach because of the Pentium 4 engineering behind it. It's just slow. But if you can crack it offline, which is most of it, then you'll be okay. At the ISU CDC, they have passwords in this format. They have a consonant, vowel, consonant, 2 digits, and then another consonant, vowel, consonant. And once this was figured out, it helped us a lot. So Tom Pohl often manages to get into a box and dump a list of hashes, but he can't get into the other box because he's too busy working on another team already. So I'm like, hey, give me the hashes. And when he gives me the hashes, I run them through a word list and I try and crack them. So it's always lowercase. You can calculate the entropy of any of these by the commutable addition in this case, since I don't know how to explain that properly, sorry. But there are 21 characters that are lowercase consonants. There are 5 characters that are possible for the vowels, and then 10 possible digits. I figured this would be a 4 gig word list and was not impractical for me to generate or carry around with me potentially to the competition, or just leave it at home and SSH into my box. This Google link is to the script that I came up with that generates this. It actually runs, I believe, a bash script that then generates the Perl script that then generates all the passwords. I am not a very good coder, so it actually would cause my RAM to run out. It was trying to use several hundred gigs of RAM in the process. So instead I decided to just dump it out more often instead of trying to generate it all in memory. So it actually prints out the vowels and consonants and string concatenates them all together in the right order to produce the word list. A better way to do this, as Jake mentioned, is hashcat masks. So hashcat is this tool that cracks passwords, and I love it. There are a few other tools. I'll get into that just a little bit later. But hashcat is designed to be fast, and in general it is. It's great with using GPUs, both AMD's and NVIDIA, as long as you have the drivers for it. And recently they upped their CPU support a bit and unified everything into one binary. It used to be that you had to download the specific hashcat for what you're doing. So OCL hashcat was for the AMD stuff. CUDA hashcat was for the NVIDIA stuff, and then just plain hashcat was if you wanted to use CPU. Since I believe version 3, it's unified into one binary blob that you can download and run whatever you want with it. So what this does is the A3, it's actually considered their brute force mode when you're using a mask. And then from there, you can tell it, the 1, the 2, the whatever are your different parameters. So I'm telling it, whenever I put a 1, do any of these characters. So all the consonants. Whenever I put in a 2, do any of these characters, the vowels. And then I want you to run consonant, vowel, consonant, digit, digit, consonant, vowel, consonant. So it's the same thing as the word list I generated, except it picks the order, I don't pick the order. And it's about 10,000 hashes a second faster. So if I really don't know what it is and I want speed, I'm going to do it this way from now on. Another popular program is John the Ripper. It's been around for a while. They have some sort of Android port that's called Hash Suite. Why you would run a password cracker on your phone, I'm not sure. Maybe you don't like your battery. Pocket Warmer, I mean, Note 7, anyone? They have pro versions for the desktop. I haven't played with those. It looks like there are no actual releases since 2013, according to their GitHub page, but they do have recent activity. So even though there's not an official release, they seem to be doing something, which is good. This is an example of what John looks like. I didn't wait for it to finish. I was impatient. But you can see the fork 4, that's multi-threaded. Anytime you're cracking passwords, you wanted the goal is to figure out the password, so why sit around and wait for it? So instead of just having one thread that's going, trying to do it, it's multi-threaded, pop it out, let 4 cores work on it instead of just the one. I specify the word list and then the hash that I was using for this demo because I knew that it was going to be near the top of the word list. Hashcat, as I mentioned, it's great for GPU. It can use CPU. It was the main focus of my talk, and so I decided to talk about other things too. I've got a demo of it here a little bit later on. If you're going to try and use it over SSH, test it ahead of time. It is really goofy with drivers. If you've ever dealt with NVIDIA drivers on Linux, you probably have an idea what I'm talking about anyways. Or maybe graphics drivers in general. I've never tried AMD drivers on Linux. Something caused it to break between when I went to bed running it. I ran it locally, went to bed, woke up the next morning, went to Ames, and it didn't work. So I spent 2 hours troubleshooting NVIDIA drivers trying to get it to work. If I would have been more awake, it might have been an hour and a half, but still. If you're going to use it remote, test it ahead of time, and don't run updates, because updates can break it because of the kernel modules, and it can be a mess. Another couple popular programs are, I believe it's Oafcrack, which comes on a live CD. I've used it before. It's great if it has a weak password. It actually uses rainbow tables, which are generated by Rainbow Crack, which is why that's up here. The Rainbow Crack is a generator for rainbow tables. And Oafcrack, they actually included on, at least back when I used it, they included on the disk a miniature rainbow table for like the first however many passwords they decided to do with it. I don't know how to pronounce this third one, the Loafcrack. It's a commercial password cracker. I've never touched it, but I have heard about it, and I've heard decent things about it. If you're on a Windows machine, Cane Enable is great for some password recovery stuff. It made it, back in the day, it made it really easy for like when you'd store the Wi-Fi password, you wouldn't remember it, or when Internet Explorer stored passwords, it puts them all into one big nice view. So even though it's not really cracking anything per se, I thought it still applied to put it here because it was a really great tool back in the day, and it's, as far as I know, it still works. Does anyone know for sure? If it does, okay, awesome. So rainbow tables, as I mentioned, they're pre-computed. They're really only good without a salt, though. As I showed you earlier that we had a salt there, a rainbow table wouldn't really be any good for that unless I happen to have made a rainbow table with that salt. But that's why it's important if you're using a hash function to salt the passwords and use a different salt for each password, so that rainbow tables are useless at that point. If there's no salt, obviously it's really easy because there's no salt. Also, if you use a static salt, which is the same salt for every single password, then if somebody figures out your salt somehow, they could just generate a rainbow table using that salt, and you're kind of back to square one. It can be as big as you want, as I mentioned. I found someone selling 6 terabyte drives. I don't know that I'd want to ever do that much with it, but if you want to pay for a 6 terabyte drive, they'll ship it to you. FedEx. Hashcat. So this is basically what my script does. It takes the hashcat binary. It says the mode, take it as a parameter on the command line, which 1800 is what you use for SHA 512 crypt, which is what's used in the Linux password file. A0 tells it it's a word list. I'm telling it to output to outfile, which is another parameter in the script, and I will have this linked on GitHub. I'm going to have a link to my presentation here at the end, and if you want to look at the speaker notes, there's a lot more fun stuff there. After that, I just link to the word list, and then this is how I run it. The CUDA hashcat script, and the hash file that I want, and then a little 1800. This is using a mask. This would be the command that you would use to do the exact same thing, although this is a bit more spelled out since it's not in script form. So you have the binary. You have the output is the passwords file, because I tend to realize I'm running it from a wrong terminal or something like that. I forgot to run screen to be able to resume easily. I like to have the full ISO date path on my found passwords file, which is why that's in there. Again, this was the M1800. I think that is a typo. I will double check that when I get home and fix it one way or another. Because if you're using, M1800, that's right, that's the hash type. Which again tells you SHA 512 in this case is 1800. If you look on Hashcat's website, they're really well documented. They give you these little codes, the M1800, the M1600, the whatever it needs to be. And I can include that link too. I believe it's in my script as well. Googling and finding the command is generally the easy part. Getting it to run's a bit harder. Again, driver issues. I'd be happy to help anyone if you want to learn. Here is a screenshot of what it looks like as it's just started. It gives you all this output. You can see I'm running it on a 1070. This is its primary purpose, is cracking passwords. It has temperature triggers so that you don't burn up your GPU if you don't want to. You can disable it. Not sure if you'd want to or not unless you're having issues. After it's running for a bit, you might want to hit S. S will pop out a little status thing like this, and it'll tell you what's going on. So it'll tell you, here's your file you're using. It's the word list. Hash target, what it's currently working on. What type of hash. It's an SHA 512 crypt. You can see that it's been running for 3 minutes and 10 seconds, and it knows it will be done in about an hour and 22 minutes based on how fast it's going, which at this point was around 94,000 hashes a second, or 94,000 password guesses a second, since I'm just using one password hash and a massive list of passwords. And yeah, my goal was 90 minutes, and I made it under that as far as what it's capable of for the task at hand at the Iowa State thing. You can see I actually switched what I was running there. So in the previous screenshot, it was a dictionary attack. In this one, it's actually using a mask, which is why that changed, even though I'm still cracking the same hash. Also, you can see it's a little bit faster there, but that's a bit more pronounced once you optimize it, which I hadn't at this point, and figured out all the driver issues and such. When it's all done, in your found passwords file, you'll get something like this. You have the big long hash, and then a colon, and then there's your password. So thanks, Tom, for pulling that hash. Came in handy. I think we broke into a couple boxes with that. Here is what it did when I was running the script here. This is not a live demo. I didn't trust myself much. So you can see I'm just seeing, I call it sand. It's my sandbox. In case I break anything, it's all self-contained in there. So I just ran it and cracked I haven't cracked the password yet. I'm checking my hash file. There's my hash. Here's Tom's hashes that he gave me the last competition. And then here we go. Let's see if I still call it CUDA hashcat script back from when it was CUDA hashcat. And here's where I'm using a dictionary attack with my script. I'm going to edit that to use mask attacks in the future. It runs for a little bit, gets around 100,000 hashes per second, and it's done because it was a password near the top of the list. So that's all there is to it, apart from the waiting. You will have to wait a while if this is an actual password attack. For the sake of time and boringness, I didn't think you'd want to wait around for 85 minutes for it to crack one of our actual passwords, so I decided to speed it up a little bit. This is an example using a mask attack. Very similar. I started moving the cursor back and then realized I could just click and drag. Noob here. So the M1800 again tells it the hash type, and this is not using the script. This is all spelled out. If you have the binary unpacked, then that first little bit will be whatever your path is. Again, the links will be in the presentation. If you want to pause it and read every little character, you can. It actually runs a little bit slower in this test. I'm not sure why until it warns me that, hey, you forgot to append W3, so try that. I'm like, oh yeah. So I do that, and then once it starts up here, you can see it goes a little bit faster. So I'm getting around 104, 110,000 hashes per second, which when you've only got, a few million or a few billion, it'll go pretty quick. Especially if you build a rig. They actually have companies that sell rigs that are just GPU. They have a little bit of CPU, but they have like 8 or 9 GPUs lined up inside, designed specifically for password cracking. They cost around $12,000, I think, and they're designed for, I guess, whoever wants to buy them, pen testers and whatnot. Beyond passwords, since passwords can be cracked, we need to be looking, as Ben mentioned, toward replacements. Passwords are what they are. They're here to stay for a while. Hopefully we can get past them. In the meantime, we're trying to supplement them. Fortunately, MFA or multi-factor authentication and 2FA or two-factor authentication are gaining some traction. Multi-factor uses a bunch of different factors, whereas 2 is just two-factor. So two-factor authentication takes the principle of something you know, which is your password, and something you have, which is some physical device of some sort. Or at least that's the theory behind it. There are a few problems which I'll go into, but for the most part, it's something you know, something you have. The something you have is useless without the password. The something you know, the password is useless without the something you have. Notes to myself. Next slide. So, the basic principle behind what they call the one-time passwords, not to be confused with one-time pad, which is a different concept, is that you have this something you have, and you either start at a counter and you do something to that thing every time, or you start with a time and you do something to it every time. So the HOTP is HMAC-based one-time passwords, and while I don't fully understand it, and if I'm wrong, again, someone correct me, but at a very, very, very basic dumbed-down example, it'd be like, okay, we're going to start at 102, and every time we'll add 5 and we'll subtract 2. And since both Google, who you're going to be authenticating with, and your phone, which holds the little fancy app, and your phone's then the physical thing that you have, know this, and you've logged in 3 times, you end up the same number. TOTP is similar, only it's based on the current time. So if your devices both know the current time and you just do some formula to that, that's my way of thinking about the TOTP. Some hardware for two-factor authentication. These are the little RSID things. They're probably one of the most noticeable because a lot of people have seen them. Another hardware device that's gaining traction is the YubiKey, especially the U2F. This guy's 18 bucks. If you don't have one of these and you don't have two-factor because you don't want to have to pull out your phone every time, buy one of these. No excuse. 18 bucks. If I can afford it, you can afford it. There are apps for it. Google Authenticator is probably one of the more popular ones. They help sort of kick off the whole thing. It works on tablets, works on phones, iOS, Android, and I'm not sure. I don't think they've branched out to Windows Phone yet. There's also Authy. Authy and Duo. I couldn't figure out Duo the first time I tried, and then I tried the second time and I got it. So maybe it was user error. I got Authy on the first try. The thing with Authy, though, and I'm not sure about Duo, Authy will sync your codes up to the cloud and encrypt them for you and all that. So with Google Authenticator, it's stored just on the one device that you use to take the little picture of the QR code during setup. Whereas with Authy, it remembers that and then syncs it up to the cloud. So in some ways, it's a little bit sketchy, but the convenience factor is there. You don't have to have all the devices you want to set up with you at the same time. The only real way to set up more than one TOTP, which is what these QR codes use that I'm going to show you here in a minute, which is what Google and Dropbox and all the websites that are supporting the two-factor auth with a QR code for setup, they're all TOTP because your phone has a clock on it and the website has a clock on it, and that works. What's interesting about it is they say you can only, especially Google Authenticator, you can only set up the one device. If you point multiple devices at it at the same time, so they all have clocks, they'll all sync up. And even if you don't do it at the same time, you can actually use it later, as I found, because it's still the same seed. So if you want to print off that barcode and use it later, you better keep good track of that barcode. Authy was a bit frustrating to make slides for. It didn't want to let me take screenshots. I can't imagine why. But anyhow, it was complaining about that, so I said, fine, I'll just take a picture of the screen with my other device. This is what not to do. This is a real thing. If you're doing this at home, yeah, exactly. Thank you. And this is probably why Authy did this, because they're like, we know there are idiots out there. We're going to try and save them from themselves. So instead, I used a different device and managed to get decent-looking screenshots. One of the cool things that I discovered I like about Authy is they have these sort of two views. You've got the one where you've got a list, and you can click on it. And then you've got this, and it has the list down here at the bottom, and you can click on them and pick through whatever for all your different accounts. Enabling two-factor authentication. So this is what the URL looks like, or the URI that's encoded in that barcode. It has the OTP auth, blah, 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 has your email address. So first it has the service, it has the email address, and it has the secret. This is an actual secret that has since been obsoleted. So you can try and use it for stuff, but it won't work. The %3a is a colon, and the %40 is an @ sign. So it's basically colon, Google colon test at gmail.com. If you have an app on your phone that you don't know how to use, or if you don't have an app yet, download it, and you can take a picture of this, and it will set up test@gmail.com two-factor authentication for you. It won't actually work, but it'll show you how the app works. So if you want to set up your actual accounts when you get home, not in front of someone where they can take a picture over your shoulder, feel free to take a picture of this now, and you can set it up. It'll start generating codes, and it'll say that your account's test@gmail.com, but I wouldn't recommend trying to use it to log into that. SMS two-factor is generally a bad idea. The cellular network is vulnerable to attacks. It's generally not transmitted securely. And often when they provide you with the option for SMS two-factor, they by default will allow you to recover your account using SMS, which has been proven a couple times to be bad for people, because all you really need then is a phone number and the email address. You don't need the password if you can recover it through the phone network. If you've managed to compromise some part of the phone network where you're grabbing SMS codes, or push bullet. If anyone knows a push bullet or iMessage where they sync to multiple devices, if somebody knows your phone number and they know your email, they don't need to know your password if the service that they're trying to get into supports recovery via SMS. That's the main reason I'm against SMS two-factor. It's not the two-factor in and of itself. It's that the way they implement it, a lot of times, by default, there is that recovery option, which is why on my accounts, whenever, like Google, for example, they want you to set it up with a phone for starters. So I go in, I set it up with the phone, I enable the two-factor codes and YubiKeys and all that, and then I disable the phone. I don't want people to be able to hack the phone network and then hack me. They can social engineer me if they want me. This is another example. I used for a while Google Voice for one of my SMS two-factor, and this is what it looks like coming in, and I can only imagine if you don't have a passcode or if you have notifications set to show on your phone, it could just, somebody knows your phone number, they're like, oh hey, let's try this, I know his email too, and looks over at your phone, and hopefully your attackers aren't that close to you, but you never know. Other passwords, Wi-Fi, let me go back. I want to do the live demo of this, just to show you how easy it is, and then I'll go back and I'll talk briefly about Wi-Fi, and then I'll be done. Give me a moment. So here's a dummy account I've set up, and if we go to our settings, I should probably have this display mirrored, but I don't. If we go to our settings, sign in and security, and you can all have my two-factor codes to this one. I don't care about this one. You don't know the password yet. Security check. No, I don't want the checkup. I don't want the checkup. I want to go back. Live demos are always fun. Signing into Google, two-step verification. We want to turn that on. Okay, so for setup, I am going to do a phone call, and after this, if any of you, let me just see it, show of hands. How many of you currently have two-factor enabled somewhere? You've set this up before. Okay, that's a lot of people. So this is probably a review for most of you. I didn't see all hands, so if I can do it in however many minutes, you can go home and show everyone else how to do it. Unless you just want me to skip that part. No, don't skip. Keep going. Okay. Live stream my phone number. We might want to edit that part out later if we can. Let me go back to, where am I? Here I am. It's really memorable. So we wait for them to call. My phone's on vibrate, but they called.
Thank you for using phone verification. Remember, you should not share this code with anyone else, and no one from Google will ever ask for this code.
No one from Google will ever ask for it.
It is 20621 5. Again, your code
In
is
case you missed it.
20621 5. Goodbye.
So great, we've just turned on two-factor authentication on our Google account. From here, you can set up backup codes. It'll show you all the backup codes for your account, which I will be getting new codes after this presentation. Don't worry, even though it's a dummy account. The Authenticator app. I'm not sure why they put Android or iPhone, because the codes are the same for both. I've tested them. They're cross-platform. You don't need to worry about that. If I was able to generate a barcode for you earlier, don't worry, Google's got your back covered. It's a little bit small here, but all you need to do is open your two-factor app wherever you keep it stored. Hit the little add button in the corner, scan barcode, take a picture if I can aim at the screen. And now I've got another two-factor added to my Google Authenticator account. And it wants the code that you see in the app just to make sure it's working, and if your barcode misscanned but still was proper. There, ta-da! Yeah, sure. Yeah, that's what I just entered. Give me my next code. Oh, you gotta wait 10 seconds. So the other thing you can do that's real fun are these little YubiKey guys. This one's the Neo. Thanks, Brandon, for letting me borrow his Neo. I liked it so much I went out and bought one on my own. The new Neos can act as a U2F or universal second factor. The older ones cannot. But again, they have those little blue ones, $18. That's all they do. You can add a security key. And yes, it's with me. And I see the little light blink, and I press the button when the light blinks. And I press the button when the light blinks, and it's a live demo, so it doesn't work. There it is. Security key registered. So now once Tom Pohl figures out my password and he steals my security key or doesn't delete his thing, he can get into my dummy account. Back to this guy, F11, where am I? And apparently that wasn't the right tab. I wasn't in present mode. Give me a minute here. Here we are. Okay, so just wanted to touch briefly on Wi-Fi passwords before I wrap it up. So, well, I'm not really covering them. Maybe in another talk if this wasn't too boring for you. They typically are a form of symmetric encryption, which isn't the type where you store a hash and then are just checking the hash. It's actually encrypting data that goes back and forth. And if you can capture with WEP, it's really easy. You just capture what they call the IVs or initialization vectors. And the software that does that can also analyze them and then brute force it. Back in 2009, as part of that CTAN class I talked about, they asked for a volunteer to crack the WEP password. And I'm like, oh yeah, sure, why not? Power on to power off was 15 minutes. It was a Celeron that was obsolete back in 2009. So if that can crack WEP and you have WEP enabled at home, tell me where you live, and I'll help you secure it. I'll set it to something you'll never guess. WPA 2 is a bit different. It uses, I don't remember what type of encryption, but you capture the four-way handshake and then you run it through a GPU just like Hashcat and hope for the best. This is why part of the reason I'm not currently doing a demo on the cracking of it. That device is dead. So yeah, the little Asus 2G didn't work too well. But if you have any questions, I'll be around afterwards to chit chat. And here's some contact info for me. The presentation link is down here in the corner. Not sure if you can see it. It's on the back screen too. That's why I keep looking back there. Sort of figure out what slide I'm on without turning around. Any questions at the moment? No? Okay, I'll wrap up myself and whoever's next.